Any one of this alpha hydrogen will shift to the oxygen atom here. Aldehydes and ketones having at least one methyl group. So this is important part here. The aldehydes and ketones undergo a number of reactions due to the acidic nature of this alpha hydrogen. If alpha hydrogen is not available, aldol condensation will not take place. Okay. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 5 of the chapter Aldehydes, Ketones and Carboxylic Acid. So in the last session, we continued with the various chemical properties, right? So the first one was condensation of reactions with derivatives of ammonia, then Clemmensen reduction, Wolff-Kishner reduction, as well as the various tests to distinguish aldehydes and ketones were discussed. So in today's session, we are going to continue with the set of reactions of ketones. So the first one is oxidation of methyl ketones we are going to discuss, and the next one is reactions due to alpha hydrogen, aldol condensation, cross aldol condensation, Cannizzaro reactions, electrophilic substitution reactions of aldehydes and ketones, as well as the uses of aldehydes and ketones. So by this, we'll come to an end to the discussion of aldehydes and ketones, and in the next session, we are going to start with carboxylic acids, right? So the first one is oxidation of methyl ketones, which is also called as haloform reaction. So aldehydes and ketones having at least one methyl group. So this is important part here. You know, aldehyde is RCHO and ketone is RCOR'. So in both these cases, one should be methyl group. That means in aldehyde, of course, this alkyl group should be methyl. Okay, and in ketone, either of this should be a methyl group. Then only haloform reaction will take place. Okay, so at least one methyl group linked to the carbonyl carbon are oxidized by sodium hypohalite to sodium salts of carboxylic acid with one carbon atom less than that of the parent compound. The methyl group is converted into haloform. This reaction is called as haloform reaction. So what is the reaction happening here is, let's take an example of a ketone here, wherein RCOCH3. So that means one alkyl group should be a methyl group. It is going to react with sodium hypohalite. Okay, so the halogen can be any one, chlorine, bromine or iodine. So what is happening here? NaOH, this is called as sodium hypohalite. Okay, so this is going to react with 3 moles of sodium hypohalite. What is going to happen? To this, the ONA is going to get attached to the carbon and the CH3 and halogen together will form the CHX3, which is called as the haloform. So if it is chlorine which we are using, instead of this X, if it is chlorine which we are using, we'll get chloroform. Bromine, bromoform, iodine if you are using, iodoform will be obtained. Clear? So, if you are using acetone, CH3COCH3, to which we are adding sodium hypoiodide we are using, what is going to happen? So, we are going to get CH3CO and this ONA will get attached to the carbon. So, we will get a sodium salt of carboxylic acid. Which carboxylic acid? Acetic acid. CH3COONA. This is the sodium salt, right? Instead of CH3COOH, you have Na here. And this CH3 and iodine will form the iodoform. Clear? Now, the next one is reactions due to alpha hydrogen. So, apart from all these reactions that we have studied, so in the case of aldehydes and ketones, it is having a special type of reactions due to the presence of alpha hydrogen. So, those aldehydes and ketones which are having alpha hydrogen, they are able to undergo a particular set of reactions. So, what is this alpha hydrogen? Let's see. In addition to nucleophilic additions, aldehydes and ketones show an unusual acidity of hydrogen atoms due to the alpha carbons. So alpha carbons means, as you can see here, this is your aldehyde, CHO, right? So this is the carbon atom which is present in the functional group. Adjacent to that, which carbon is present, that is called as the alpha carbon. So this is your alpha carbon and these 3 are called as the alpha hydrogen. So because in this particular, which one is this? Acetal, right? Or ethanol. So in this, you are having an alpha hydrogen. But let us consider formaldehyde, HCHO. So this itself is the carbon atom which is having the functional group. So in formaldehyde, that is the first aldehyde, there is no alpha hydrogen. Clear? Moving on to the next one, CH3COCH3. So this is the functional group and the carbon containing the functional group. Both these are the alpha carbon atoms. Clear? And all these 1, 2, 3, 4, 5, 6, all of them are alpha hydrogens which is present. Clear? Okay. So because of the presence of this alpha hydrogen, it shows acidity, and because of that, there is a set of reactions which can it undergo. Okay. So the aldehydes and ketones undergo a number of reactions due to the acidic nature of this alpha hydrogen, because this alpha hydrogen can be released to the oxygen. So we'll see that the acidity of alpha hydrogen atoms of carbonyl compounds is due to the strong electron withdrawing effect of the carbonyl group and the resonance stabilization of the conjugate base. So because of this, the alpha hydrogen will have acidity. Now, moving on to the first reaction, which is a very important reaction called as aldol condensation. Aldol condensation, because what is going to happen? An aldol is formed. What is aldol? We are going to see. Condensation means water is going to get removed here. So, let's see. Aldehydes and ketones having at least one alpha hydrogen. Okay, so this aldol condensation will only take place, or this reaction can only happen if your aldehyde or ketone is having an alpha hydrogen. If alpha hydrogen is not available, aldol condensation will not take place. Okay, undergo a reaction in the presence of dilute alkali as a catalyst to form beta hydroxyaldehyde. So what will be formed? Beta hydroxyaldehyde, that is called as aldol. Okay, or beta hydroxy ketones, which is called as ketol respectively. This is known as aldol reaction. The aldol and ketol, once aldol and ketol is formed, readily lose water to give alpha beta unsaturated carbonyl compounds, which are aldol condensation products, and the reaction is called as aldol condensation. So first what is going to happen is your aldehyde or ketone is going to condense with itself. Okay, 2 moles we are going to take, or 2 molecules of aldehydes or ketones will take. It will undergo self condensation and form aldol, which on the removal of water, what you are going to get? Aldol will be formed. So let's start with the reaction here. 2 moles of ethanol we have taken. So what is the first point to check? Whether it is having an alpha hydrogen atom. So this is the carbon atom which is attached to the functional group. So this is the first adjacent carbon which is having 3 hydrogen atoms. So all these 3 are alpha hydrogen itself. So this 2 moles is going to undergo self condensation. Okay, both of them will undergo self condensation and form aldol. So how this is happening is, let's take 1 mole CH3CHO and another mole, I'm just going to write it like this, CH3CH double bond O. So now what is happening here is, there will be a transfer of alpha hydrogen from 1 mole of the aldehyde to the oxygen atom of the other aldehyde. That means you have 3 hydrogen atoms here. All of these are alpha hydrogen. 1, 2, 3. All of these are alpha hydrogen. Any one of this alpha hydrogen will shift to the oxygen atom here. Okay. So what is going to happen? OH you are going to get here. Right, OH you are going to get here, and this will become CH2. This hydrogen will get shifted to the oxygen atom. So what you will get? CH3 will be there and CH will be there, to which hydrogen is attached. So you will get CHOH and you will have CH2 and CHO. So this is the aldol which is being formed here. Now what you have to remember, when hydroxyl group and hydrogen is present in adjacent carbon atoms, water can be easily removed from there. So you will have CH3, CHOH, CH2, CHO, right? So from here, OH and 1 hydrogen from here will be removed. That is H2O will be removed. So H2O is removing means what will happen here? A double bond will be formed here. So you'll get CH3CH double bond CH-CHO. That is butane 2-enol you are going to get. Clear? Now let's take an example of a ketone, CH3COCH3. So again, what is going to happen? 2 molecules we have taken. So from 1 molecule, like in this case we have discussed, from 1 molecule of the ketone, 1 alpha hydrogen is going to get attached to this oxygen and form OH. So we'll get CH3COH you are going to get, right? So CH3COH and the other CH3 is shown here, and from the next molecule you will have a CH2COCH3. That's from the next molecule. So from here again, what is going to happen? This OH and H is going to get removed, and you will have a double bond which is going to be formed here. That is CH3CCH3 double bond CHCOCH3. Clear? So now that is aldol condensation. Next one you have is cross aldol condensation. So in aldol condensation, 2 molecules we are taking of the same aldehyde and same ketone. So we have taken 2 ethanol here and 2 molecules of propanone here. Both are same. But coming on to cross aldol condensation, either we are going to take 2 different aldehydes or else 2 different ketones, or else we can also take 1 aldehyde and 1 ketone. Okay, all of this comes under cross-aldol condensation. So aldol condensation is not confined to similar molecules of aldehydes and ketones. It can also take place between different aldehydes and ketones. When aldol condensation is carried out between two different aldehydes on different ketones or between an aldehyde and a ketone, it is called as cross-aldol condensation. Clear? So we have taken what? Ethanol as well as propanol here. Okay, ethanol and propanol. We can't take methanol here, which is the first one, because there is no alpha hydrogen present there. Okay, so you can start with ethanol and propanol. So what is going to happen is you are going to get 4 sets of products here. How we are getting 4 sets of products? 4 possibilities can take place here. So you have 2 different aldehydes here. So one ethanol can react with another ethanol and form one product. Okay, that is simple aldol. That is, same will undergo self-condensation. Another possibility is propanol and another molecule of propanol can undergo aldol condensation and form an aldol. Clear? Now, another possibility is methanol and propanol can react in 2 different ways. That means ethanol can give its alpha hydrogen and form a product. Another possibility is propanol can give its alpha hydrogen and form another product. That way, 4 products will be formed. So these 2 we have already studied in the previous one. That is how self-aldol condensation will take place. That is the same aldehyde we are using. So by the reaction of this different aldehydes, 2 products will be formed by the self-aldol condensation of ethanol and propanol. And then the other 2 will be formed by the cross-aldol condensation between ethanol and propanol. In one case, ethanol will be giving the alpha hydrogen and another one, propanol, will be giving the alpha hydrogen. So, these are the 2 products that you are going to get on simple aldol condensation, and these are the 2 products you are going to get on cross-aldol condensation, which is a mixture of the ethanol and propanol. So, this is just with the ethanol and this is just from the propanol. This is a mixture of ethanol and propanol. This is also a mixture of ethanol and propanol. So 4 different products will be formed in cross-aldol condensation always, okay, based on which aldehyde you are using. So it can be 2 different aldehydes, 2 different ketones, and one can be one aldehyde and another one can be ketone as well. Now, ketones can also be used as one component in cross-aldol condensation, not just aldehyde, ketones can undergo. So here we have taken benzaldehyde, CHO, cross-aldol condensation we are discussing, okay. This is benzaldehyde, which is one aldehyde, and CH3CO and phenyl group, this is called as acetophenone. So here what is happening? So here alpha hydrogen from the ketone, acetophenone, is going to get attached to the oxygen atom here. So what you are going to get? Benzene will be there, that is a phenyl group. COH you are going to get, COH, and this hydrogen is already there, and from here you will get the CH2, which is going to get attached to the carbon. This whole part, that is, this whole part is going to get attached to the carbon. So, we will get CH2, CO and the phenyl group, which is going to undergo condensation, removal of water. That means OH and H will be removed. So, there will be a double bond which is going to form here. So, we will get phenyl group, CH, double bond CH, CO and the phenyl group. So, that is the addition product that you are going to get. Now, moving on to the next reaction, that is Cannizzaro reaction. Aldehydes which do not contain alpha hydrogen, okay, which do not contain alpha hydrogen atom, such as formaldehyde, which is the first aldehyde, and benzaldehyde, that is an aromatic aldehyde which also doesn't contain alpha hydrogen, undergo mutual oxidation and reduction on the treatment with concentrated alkali. The Cannizzaro reaction is a redox reaction in which 2 molecules of aldehyde which do not contain alpha hydrogen atom are reacted with strong alkali to produce primary alcohol and a salt of carboxylic acid. So that means the same aldehyde will undergo oxidation as well as reduction. Okay, so that is called as Cannizzaro reaction. So we can see here formaldehyde, 2 molecules we have taken here. One molecule for formaldehyde will undergo oxidation, another one will undergo reduction. So, if aldehyde is undergoing oxidation, what we will be getting there? We are going to get a acid there. So in presence of potassium hydroxide we are taking, that means a potassium salt of an acid we are going to get here. And if another molecule is undergoing reduction, what we are going to get? An alcohol will be formed here. CH3OH will be formed. That means to this we are going to add hydrogen, so you will get CH3OH. Okay. So aldehyde, one, it will form an alcohol, and another one will undergo oxidation and form a salt of carboxylic acid. So let's take another example of another compound which is not having an alpha hydrogen, that is benzaldehyde. So these two will undergo generally the reaction, Cannizzaro reaction, which are not having alpha hydrogen. Okay, so benzaldehyde, two molecules we have taken. So one will undergo reduction to form alcohol. Okay, that is called as benzyl alcohol, and another one will undergo reduction to form a sodium salt of the acid, which is benzoic acid. Clear? So till now we were discussing the reactions involving alpha hydrogen. Now moving on to the next set of reactions, that is electrophilic substitution reaction. Aromatic aldehydes and ketones undergo electrophilic substitution reaction at the ring, in which the carbonyl groups acts as a deactivating and meta-directing group. So your aldehydes are meta-directing group. This is very important to remember. So benzaldehyde we have taken, to which we are adding the nitrating mixture. That means nitration is going to happen here. So where is the nitro group is going to attack? Because the aldehyde is a meta-directing group, the nitration is going to take place in meta position. So these two are ortho position, these two are meta position. So in the meta position, the nitro group will be attached. So it is going to be meta nitro benzaldehyde. Clear? So you have to remember aldehyde is a meta directing group. Right. Now the different uses of aldehydes and ketones. In chemical industry, aldehydes and ketones are used as solvents and starting materials and reagents for the synthesis of other products. Many aldehydes and ketones, example butyraldehyde, vanillin, acetophenone, camphor, etc., are well known for their odors and flavors. So in the beginning of the chapter also we have discussed about the various uses of aldehydes, right? The commonly important carbonyl compounds are methanol, ethanol, benzaldehyde and propanol. Okay, so uses of formaldehyde, let's discuss. That's the first one, methanol, right? Methanol is used in the manufacture of bakelite, resins and other polymers. In the preparation of polymers it is used. It's 40% aqueous solution of formaldehyde known as formalin. 40% formaldehyde, 8% methanol and 52% water is used for preserving biological specimens. So in biology lab also you have seen many containers in which various species are being preserved. So they are preserved in a solution. What it is actually? It is formalin. Okay, that is also found from formaldehyde. Right. Now formaldehyde is used in the preparation of urotropin, which is used in the treatment of urinary infections. Okay, and nitration of urotropin gives RDX a powerful explosive as well. Okay, formaldehyde is also used as an antiseptic. Okay, now next one is the use of acetaldehyde, which is ethanol. Ethanol is used in the preparation of a number of organic compounds like acetic acid, ethyl acetate and butyl alcohol. Paraaldehyde, a polymer of acetaldehyde, is used in medicine as a hypnotic, and it is used also in the silvering of mirrors. Next one is use of acetone, which is ketone, right? Propanol, CH3COCH3. It is used as a solvent in the manufacture of smokeless powders, celluloid, etc. It is one of the ingredients of liquid nail polish. So in nail polish you have already observed the smell also, you know how it is, right? So that is actually what it is, acetone. Okay, that is propanone. Now the next one is benzaldehyde. It is used in the perfume industry because it is aromatic, it is having a smell. In the manufacture of dyes like malachite green, as a starting material for the synthesis of other organic compounds like benzyl chloride, cinnamic acid, etc. So by this we come to an end to the discussion of aldehydes and ketones. So till now we have discussed the various methods of preparation, the IUPAC nomenclature, the physical properties and chemical properties, and the ways to distinguish aldehydes and ketones. So by this we come to a discussion of aldehydes and ketones. In the next session we are going to start with carboxylic acid. The same way we are going to discuss carboxylic acid as well. So I hope the concepts regarding aldehydes and ketones is clear for you. So that's all for today. Thank you.